Okay, welcome to an example of a calculation, stoichiometry calculation, where we're going to look at a balanced equation, and we have this in green here that we've got 3 iron oxide will react with 2 aluminums and will form 3 iron solids and then aluminum oxide. Okay, and so up at the top here I've got a little kind of chart, if you will, a pattern you want to follow in order to get from one place to another. So on number 1, it says calculate the mass of iron 2 oxide needed to react completely with 5.55 grams of aluminum. So what you want to start with is you want to start with what you were given. And you were given the fact that you've got 5.55 grams of aluminum. And looking at that chart, the very first thing we have to do, since we can't compare grams of one substance to grams of another, we've got to find out how many moles. So the very first thing we have to do is go from grams of aluminum to moles of aluminum. And I find that out using the periodic table, look up the molar mass for aluminum, and when you do that, you'll see that 1 mole of aluminum has a molar mass of 26.98 grams. Now, in the periodic table, it's flipped. It actually says 26.98, but the reason I had to put the grams on the bottom is that's going to allow the grams here to cancel out. And now what I will be left with is I will be left with moles of aluminum. And we end up with 0.206 moles of aluminum. Now it's only when I'm in moles can I start comparing moles of aluminum to moles of iron oxide. So I'm going to start over here with my moles of the aluminum, and I now need to go from moles of aluminum to moles of iron 2 oxide. And the way I do that is with my mole ratio. And remember, we get our mole ratio by these coefficients up here. So the 2 coefficients that I'm interested in this 2 because that matches the aluminum. And I'm also interested in the 3 here because that's for the iron 2 oxide. So I want to get rid of aluminum, so I'm going to put the 2 moles of aluminum down here. And I'm going to put 3 moles of my iron 2 oxide at the top here. That's going to allow me to cancel out the moles of aluminum, and now I can find out how many moles of iron oxide I'm going to need. So we multiply everything in the numerator, and we're going to divide whatever's in the denominator. And when I do that, I get 0.309 moles of iron oxide. And if you look at this, this kind of makes sense because for every 3 moles of iron oxide, I need 2 moles of aluminum, which means then I'm going to need more moles of iron oxide. So if I have 0.206 moles of aluminum, it makes sense that I need 1.5 times for the iron oxide. Okay, now I've got to this point right here, and now I want to go from moles of iron oxide to grams of iron oxide. And the way we're going to do that is we're going to take our 0.309 moles of iron oxide, and now how do you go from moles of iron oxide to grams of iron oxide? And again, we use the molar mass from the periodic table. And so on the periodic table, we would find that there's 71.85 grams of iron oxide in every 1 mole. I'm putting the mole down here. And the reason I'm putting it down here is so it cancels out with the 0.309 moles. And I'm going to enter in the 71.85 grams of iron oxide. Notice now the moles of iron oxide cancel out. I'm going to multiply 0.309 times 71.85, and I get my answer, which is 22.2 grams of iron oxide. And you just did a gram to mole to gram conversion. And this is how we can determine when we're trying to make a product And depending on how much we want to make, we will know how much starting material. So we'll see how much reacts with one another. So stoichiometry is going to be a really important role in chemistry. All right, good luck.